Determining values of p of x. Say I have a polynomial function, p of x is equal to x squared plus 2x plus 5. I could have written this as a y equals x squared plus 2x plus 5, but writing it in this function notation actually gives me a little bit more information. So I can find my values of my function by choosing some values for x and plugging them in. I can also graph this function, but in this case we're just going to find those values. So here, if I wanted to find out what p of x is equal to when x is equal to 3, I can go ahead and substitute a 3 in for all of my x's. So everywhere I see an x, I'm just going to go ahead and substitute a 3. Now this does not mean p times x. This just means x is a function of p. So it's just functional notation that mathematicians use. So in substituting a 3 for every x, I have, instead of x squared, I have 3 squared plus 2 times x, and in this case my x is 3, so 2 times 3, plus a 5. 3 squared is 9, 2 times 3 is 6, 9 plus 6 plus 5 is 20. So p of 3 is equal to 20. Now in this notation, it actually gives me the ordered pair. I have 3 comma 20, whereas if I just had a y equals, I'd have to remember that I substituted that 3 in for x. So p of 3 is equal to 20. My ordered pair is 3 comma 20. If I were going to graph p of x, that would give me one point that satisfies our equation. I can also do this with other values. Say negative 1. Negative 1 has to be in parentheses because I'm squaring my x value, the whole x value. So negative 1 squared plus 2 times negative 1 plus 5. Negative 1 squared, this is just a 1. This is a negative 2, and this is a 5. Adding them all together, I have p of negative 1 is equal to 4. So that's another point that satisfies my equation, negative 1 comma 4. I could substitute in a 0 for x, and I find 0 squared, just squaring my x, plus 2 times 0, plus 5. That's going to give me my y-intercept. P of 0 is equal to 5, and that gives me another coordinate point. Now let's look at p of x a little bit more abstractly. So here I have my polynomial, same polynomial, and instead I want to know what p of a is. So I'm not finding a specific value, just a, so some value of a. So I do the same thing though, I'm just substituting a in for my x right here, and so I have a squared plus 2a plus 5. No like terms, I can't simplify it anymore. Now what if I wanted to know what p of x plus 4 is? So instead of an x value here, I want to know what x plus 4 is. So everywhere there's an x, I'm instead going to substitute x plus 4. So here where I have x squared, I now have x plus 4 squared, plus 2 times x, I have plus 2 times x plus 4, plus 5. I have no x values up here, so I don't need to make that substitution. Now here comes the tricky part actually, is just to do all of that calculation. So x plus 4 squared, remember I really have to write it out so I can show the distributive property there, where I distribute that x here to make x squared, and then a 4x, and then a 16. So I have two 4x's, which gives me that 8x. So I have x squared plus 8x plus 16. That's what my x plus 4 squared gave me. Plus 2 times x plus 4, I'm going to distribute the 2, and I have 2x plus 8 plus 5. Then I need to combine like terms. So I have no other x squared terms, so I just have an x squared. 8x and 2x makes a 10x. 16, 8, and 5 make 29. So p of x plus 4 gives me a new kind of parabola, x squared plus 10x plus 29. Now we can do some other things with our values of p of x. So same equation right here, and I want to find 2 times p of b. So really I'm taking p of b and I'm multiplying it by this 2. The whole thing, all of p of b. So I can rewrite that as 2 times, and then this right here, this is all p of b. So I took a b and I substituted in for my x values, so I have b squared plus 2b plus 5, and then I'm multiplying all of p of b by 2. So I'm just going to distribute the 2, and I have 2b squared plus 4b plus 10. Now let's put it all together in one last problem where we have 2 times p of x plus a. So I'm multiplying the whole thing by 2, all of p of x plus a, and I need to find this p of x plus a. So 2 times, and this right here is p of x plus a. Everywhere that there's an x up here, I'm going to substitute it in with x plus a. So instead of x squared, I have x plus a squared. And I have to have that in parentheses because I'm squaring the whole thing. Plus 2 times x plus a plus 5. And then I go ahead and do all of my calculations. X plus a times x plus a is x squared plus 2xa. I have an xa and an xa. I combine to form a 2xa plus a squared. And that's x plus a squared. And then 2, distribute that 2. I have a 2x plus a 2a from this right here, and then plus a 5. Now, I'd like to combine like terms, but I have no like terms in here at all. So I'm just going to go ahead and distribute my 2 to every single term here. And I have a total of 2x squared plus 4xa plus 2a squared plus 4x plus 4a plus 10. And there you have it, all put together.